This is the video for Chapter 3, Part 1. Alright, so the key ideas in Chapter 3 are really just all of these different measures of center, spread, and position, these numerical summaries of data. The interactive assignments do a decent job, I think, of showing how to get these. Remember, we're not going to focus on the formulas. There are formulas for mean, like if you just need to be able to find the mean or the average of a number, then yes, you need to actually be able to know if I add these numbers up and divide by however many numbers there are, then I have that value. But the more important concept, I think, in Chapter 3 is understanding which of these values go together. When do we need to use center and spread versus a measure of position? Alright, so in this chapter there aren't a lot of concepts that are at this existence level of understanding, but I would say one would probably be variance. So variance is the standard deviation squared, and I think you need to know that it exists. You need to know how to calculate it by squaring the standard deviation or being able to read it on a printout from a statistical calculator of some sort if it gives it to us. But we're not ever asked to use it, so just knowing that it exists and what it is, that it's the standard deviation squared, that's definitely one thing that would fall under the existence. The other one that we really don't use a whole lot is the range. Of course, it's the easiest one. It's just the max minus the min. But we don't actually end up using it a whole lot in trying to interpret or explain something about a data set. You may have some homework questions that ask you, what is the range, what is the standard deviation, what is the variance? But you won't end up having a lot of trying to get you to interpret the range or interpret the variance. For the most part, as far as being able to do something supported, being able to get to the statistical calculations through StatCrunch or the TI-84. Definitely, eventually, if we do this enough, you will end up being able just to remember the steps. But there's never going to be a time when I ask you to be able to use StatCrunch or use the calculator without having some sort of calculator sheet. So that's at least for my class. So you'll always have those calculator steps or the StatCrunch to rely on. So just remember that. So that's not something that you need to have memorized. But you should eventually start remembering how to do it because you've just after repetition. Another that I think can probably land in this area is going to be the z-score. That is actually a very good calculation to know. Remember, this is one of the very few formulas where we actually end up having to calculate it almost. Maybe StatCrunch will do it for us, but our calculators, TI-84, will not. That's our value that we're wanting to know, like what position does it have. We subtract the mean from that value, and then once we have that number, we divide by the standard deviation. I'm fine with you having that formula on hand if you need to calculate a z-score, but at the same time, I want you to know what that z-score is. That z-score is telling you where this value is in comparison to the mean. It's the number of standard deviations away from, and I'm going to abbreviate SD, number of standard deviations away from the mean. Now I'm going to put this on the next slide as well because the formula is something that I would say would go under this supported list, but the idea of the z-score, that's something I would like for you to just, when you hear z-score, you think, oh, that's how many standard deviations above or below the mean a value is. So hopefully we can get that part put in our brains. All right, so for this chapter, some of the big ideas that you will want to know without having to reference back to your notes uh, often, especially for a quiz or a test, is going to be something like knowing that the mean and standard deviation, and I'm going to abbreviate that SD, are what we use when we have symmetric data sets, and that we use the median and probably the interquartile range, or maybe even just the 5-number summary, when we have skewed data. So those are definitely two connections that you want to just really focus and make sure you understand. We would never give, if we were giving some sort of summary, we wouldn't give the median and standard deviation. That just wouldn't happen in a statistical situation. There will be times, in fact, that later on in the semester where I will just tell you that a distribution is normally distributed. So remember, that's going to be that symmetric, single-peaked, bell-shaped distribution that looks like that. So I'll tell you that we have a normal distribution. Something's normally distributed with a mean of, and I'll give you a number, and a standard deviation of, and I'll give you a number. And that's it. That's all I'll tell you. I'll tell you the shape, the mean, and the standard deviation. And that will be enough for us to actually answer questions about that distribution, about that sample. So we don't want to mix those up and not remember what goes with what. I'm going to put 5-number summary too, because that goes in with that median and interquartile range. And as I said earlier, the definition of a z-score. So we want to know that a z-score tells us the number of standard deviations a value is above if it's positive, or below if it's negative the mean. That's something that I would like for you to have actually understand and have stuck in your brain. So there's 3 things that I think hit into that independent, you know it at least for while we're in this class. And then, of course, there are some things that I would like for you to maintain for the lifetime. In general, I do want you to know that the mean is found by finding the sum of all the x values. So I'm going to use that Greek symbol sigma to represent the sum, divided by however many x values there are. I mean, hopefully most everyone has done this. You've added up your grades and then divided how many grades you have to figure out what your class average might be. So I want you to always be able to find the mean. I also want you to always know, I would like for you to be able to understand a percentile and what that means. So remember, a percentile tells us the percent of data below a particular value. So let's say on a standardized test, you look at your standardized test, so the TCAPs when you were in grade school, or the SAT or ACT. All of these tests have percentile ranks, and this ranking is a placement, a position that you are in relative standing to everyone else. So if you were in the 85th percentile, then that means that your score or value, so if it's not a test, if it's a height, weight, whatever, And I'm going to have to scoot this up a second. Hold on. Is higher than 85% of the rest of the people who have done whatever it is that you're being ranked on. So if you're in the 85th percentile for the ACT, you did better than 85% of the people on that test. If you're in the 85th percentile for height, then you're taller than 85% of the people in your age range, gender, and all of that. So that's what our percentile, and I feel like that's something that we should know regardless of being in a stats class. That's something that we actually end up seeing and dealing with quite often. So I would like for that to be something, hopefully, that you can keep a hold of.